All right, we're going to get started with the last presentation of this track. He made it. Phil Windley from Sovrin has made it in from New York, and he's going to talk to us about global public identity utility.
Hi, everyone. I'm trying to calm down after rushing to get here after a delayed flight, so I think we'll be good. As Zach said, I'm Phil Windley. I'm an enterprise architect at Brigham Young University, and I'm also co-founder, along with Clea Hamlin and Doc Searles, of something called the Internet Identity Workshop, which happens twice a year. And it's an unconference, so if you have something you want to speak about, come and speak. Today, I'm also the chair of a nonprofit foundation that is building a global, public, decentralized identity utility called Sovrin. I want to speak about self-sovereign identity and trust and the relationship that they have with each other. Internet identity is broken. There are far too many privacy breaches. There are too many anti-patterns. But more importantly, as Andre talked about in the last talk, there are a lot of good business cases that are too expensive because we require everybody to provide their own identity, every company, every business to provide their own identity. I'm going to talk about why I think a decentralized identity system is a solution to this and how it can provide not only better privacy and security, but also more value. I know that's a pretty tall order. I hope by the end of the talk, you'll think that I've gotten there. Why do we build identity systems? There are a number of reasons, but I maintain that one of the primary reasons we build identity systems has to do with trust. Authentication is about trust. Authentication asks a very specific trust question. Can I trust, or am I certain, with some degree of certainty, that the person at the other end of this transaction is the same person who they were last time and when they signed up for the account, and so on? Now, trust helps us believe what people say. We always evaluate the information we get based on how much we trust the source, the channel, and other aspects of that communication. Trust has evolved from something that was local and happened between people who knew each other, lived in the same village, to something that is global and happens between people who don't know each other at all. Now, we've evolved our institutions in order to do that. Banks, universities, governments are all institutions that help us trust strangers because they put in place a framework that allows us to operate within. But intermediaries like banks and governments and even universities cost money, and they take time, and often they're a threat to privacy and security. But believing what people say online is difficult because identifiers, the things we use to identify people online, are often out of context, and they don't have the connections, the linkages that we need in order to establish trust. So we build identity systems. When a site like Amazon builds an identity system, what they're doing is creating a simple trust framework. Trust frameworks allow the owner, Amazon in this case, to know things about the subjects of that particular identity system. Trust framework in this case is centralized and it's owned and it's private. Amazon uses it for their own purposes and it's subject to the terms and conditions that Amazon has set. We call these kinds of trust systems administrative identity systems because they're designed to administer identity for a particular group of people and usually in a specific domain. There are more complicated trust frameworks that allow us to establish trust across domains. Probably the most familiar to most of us is a credit card. I take my credit card from my bank and I walk into a merchant who uses a completely different bank, and I give them this little identifier, the number on it, and they trust that at the end of the day, money will be deposited into their account based on this little exchange that we just had. The reason they can do that is because there is an overarching trust administrator, in this case Visa, who has legal contracts with banks, my bank and the merchant bank. They've established business processes, and there's a set of technology. And of course, I have a contract with my bank, the merchant has a contract with their bank, and it's this link of, this chain of links that allows us to trust that this system will transfer money the way we think it will. This combination of business processes, legal agreements, and technological systems is often referred to as the BLT sandwich of a trust framework. Now, in the physical world, trust doesn't work that way, at least not all the time. It's a lot less rigid. It's a lot less scripted. Because what we do is we often rely on trustworthy credentials that people carry with them. When you go to the pharmacy to get a prescription, let's say, the pharmacist may want to know that you're over 18. And so what the pharmacist does is they ask you for a driver's license. Now, when you think about it, that's kind of out of left field. A driver's license was not built to prove that you're over 18 in a pharmacy. It was built for a particular domain, driving. And yet, we can take that trust credential, that identity credential that is built for one domain and use it in another. Now, this works because of the way a driver's license is implemented. There are a couple of things that make this happen. One, we all trust the driver's license bureau to do a pretty good job of vetting the people who get driver's licenses. We trust that they're going to establish a correct birth date. We trust that usually the address on this driver's license is correct. A second thing that makes this possible is a driver's license is a container for attributes that is difficult to forge, at least difficult enough for the purposes that we put it to. If I wanted to transfer $1 million, they probably wouldn't just accept my driver's license for that, because it may be worth forging a driver's license for $1 million. So it's good enough for the purposes we want to use it in. None of the identity systems in common use today allow us to do that same kind of transfer of trust using a third-party credential. This kind of attribute or ad hoc attribute sharing happens every day in the physical world, but it doesn't happen very often online. Consequently, when you want to transfer attributes from one online entity to another, we usually perform some kind of integration with an API or something else. We may even have to have some sort of business development deal that happens and a contractual agreement to make that happen. This is slow, complex, and costly, so it typically only happens for high-value applications. Sovrin has built a system that allows third-party credentials to be exchanged in a flexible way. Not just third-party credentials that we have designed, but third-party credentials that almost anybody can design for any purpose. So for example, an employee may have a claim from her employer that says lots of things about her employment, her salary, her position, benefits, all kinds of things. She can take that claim and use it with a bank to prove her salary to the bank. And that does not require that the bank and the employer have an integration. It doesn't require any kind of API to make that happen. So now there are three things that make Sovrin work as a distributed, decentralized, global identity utility. The first is a distributed ledger. The distributed ledger is public and permissioned. Now, if you're familiar with distributed ledgers, blockchains, those two words don't often go together. Usually we think of private permissioned ledgers and public permissionless ledgers. Sovrin is a hybrid that is public and yet permissioned. It has the same virtues as the internet. Nobody owns it, everybody can use it, and anybody can improve it. Sovrin's purpose-built ledger is designed to be performant and to scale. And in particular, we don't use a permissionless ledger with proof of work because of the cost that entails and the disincentive that gives us for creating identifiers. We want identifiers to be very cheap so that people create a lot of them. I'll talk more about that in a minute. The second thing are these decentralized identifiers. There is an emerging standard called the Decentralized Identity, or DID, specification, which defines how decentralized identifiers work. We use decentralized identifiers to provide pairwise identity for every relationship that a person enters into. On the ledger, decentralized identifiers are linked to what are called DID descriptor objects, or DDOs. A DDO is a JSON object that contains private keys, 0 or more, and endpoints, 0 or more. So if I know your DID, I can look it up on the ledger and get a private key for you and the endpoint where you want me to communicate with you. The third thing that I've already alluded to is this idea of verifiable claims. As I said, these allow third parties to provide identity owners with credentials that they can use just like they do offline. These claims are built to be extremely flexible. Anybody can specify what's in a claim by writing a claim schema onto the ledger and then use that in any claim that they want to provide. In addition to the idea of verifiable claims, Sovrin also supports zero-knowledge proofs. So in my previous example, where this employee was using her claim from her employer to prove her salary to the bank, she doesn't need to reveal everything that's in that claim to the bank. She only needs to reveal the information the bank wants. In this case, it was her salary. Now let's talk about the word sovereign for a minute, because this is often described as a self-sovereign identity systems, and sometimes that word sovereign makes people nervous. But I think that's based on a misunderstanding about what sovereignty is. In 1648, a number of warring parties signed what are known as the Treaties of Westphalia, which ended several decades-long religious wars that were happening in Europe. More importantly, the Treaties of Westphalia established our modern notion of the nation-state and the integrity of borders. Now, what sovereignty means in the world of nation-states is that a particular nation has control of all of the area within its border, and outside of its border, somebody else has control. What this does is it leads to bilateral and multilateral agreements between parties as peers. This is the same thing that's important in a self-sovereign identity system. It's this notion of borders that say where an individual has control and where other entities have control that forces the bilateral and multilateral agreements that create peer-to-peer relationships in an identity system. The beauty of self-sovereign identity isn't complete control, because that doesn't work. Right? You can be the king of your island, but you're still just the king of an island. The beauty of self-sovereign identity is that it creates relationships where people can talk to each other as peers. Now, another vital feature of decentralized identity, especially for a public ledger, is privacy. Privacy by design is baked deep into the architecture and is reflected in three fundamental features. First, I talked about decentralized identifiers. Sovrin creates decentralized identifiers in a way that is pairwise pseudonymous, and it does it that way by default in order to prevent correlation. So my bank and my employer are each going to have a different DID for me. And therefore, they can't talk behind my back about me because they don't have any way to correlate, at least based on the identifiers that I've given them. The second thing that's really important is that private information is never written to the ledger. That keeps, even in encrypted form, that keeps private information private. And the third thing is this idea that I mentioned earlier of zero-knowledge proofs that allow me to share just the information that needs to be shared. Now, trust frameworks of the past, and I'm speaking about online digital trust frameworks, were custom built for a particular purpose. Sovrin represents a universal trust framework. It represents a system that anybody who needs to create trust can use to build their own system. So Sovrin provides the benefits of a trustworthy identity system without each participant having to build their own. So imagine, for example, some of the companies that we associate with the sharing economy, like Uber or Lyft or Airbnb. These companies survive because they've created a trust platform that allows drivers and riders or renters and landlords to trust each other. But each of them has had to build that trust framework on their own with whatever tools they could come up with. And they've done a pretty good job because they have succeeded. How many other sharing economy companies didn't get that trust framework right? Couldn't build the infrastructure necessary to do that or didn't have the money to do it. So that's the kind of thing that Sovrin provides. Sovrin also provides accessible provenance for these trust interactions, because one of the things that makes trust work is the idea that you can hold accountable, that you can take recourse against someone when they are untrustworthy. You downrate them on Lyft, or you downrate them as a renter in Airbnb. And that keeps everybody acting, or keeps most people at least, being good actors. Sovrin has a rock-solid revocation model, which allows these kind of trustworthy claims to be easily revoked when they're no longer valid. Now, you can't really talk about a global identity system without dealing with GDPR. Sovrin provides the means of securely sharing information through sovereign trustworthy claims, as we've talked about. As part of this, Sovrin provides the means for using claims in a way that preserves privacy, as we've talked about with zero-knowledge proofs. But it also provides consent receipts that say what has been shared and what terms was it shared under, so that both parties are well aware of the information that's been shared and the terms. Now let's talk a little bit about use cases. First use case that everybody asks about is just authentication. And yeah, the idea is that a global, decentralized public utility for identity can get rid of passwords once and for all. I won't go into the details, but I'm happy to describe it if anybody wants to talk about that. But it uses fairly well-known techniques for using public keys for authentication. Healthcare. We're working with a partner, for example, as a use case called Doctors Link, based in the UK. Apparently, in the UK health system, doctors and other healthcare providers, nurses, etc., are much more likely to be in a temporary work situation than they are in the US, for example. And as a result, Manit Najjar, who is the guy that runs Doctors Link, told me that some healthcare professionals spend up to 5 days a year, 5 work days a year, essentially exchanging credentials to prove that they have the right credentials. Is costly, it wastes time, it wastes money, and so what they're doing is they're using Sovrin to essentially create trustworthy claims that represent these healthcare professionals' credentials. Now, if you think about what happens right now, in the current situation, there's a government agency that has to maintain a highly reliable 24/7 web service that hospitals all have to integrate with so that they can check credentials anytime a temporary healthcare worker shows up. In a Sovrin-based system, what happens is the healthcare professional carries their own credential, and yet the hospital can validate that credential is trustworthy. And on the other side, the agency doesn't have to maintain this highly reliable 24/7 web service for this to happen. So it reduces costs all the way around and saves people time. My own institution, Brigham Young University, is exploring with a pilot the use of Sovrin for education credentials. Now, the first place everybody goes when you talk about this is transcripts, because we're all familiar with the transcripts. And even in 2017, we hire an army of students every winter to essentially transcribe transcripts that still come as PDFs from high schools and other universities. There's no electronic system that works to make that currently exists to make this work. So that's an obvious place to use claims, is in order to transfer these kind of high-level, coarse-grained identity credentials that we call transcripts. What we're exploring is a way of using them in a more fine-grained manner to create claims about individual students' learning activities. Could be as fine-grained as Sally took a test and got an A in this particular course. What this does is this allows us to be more modular in how we put courses together and even work with other institutions to make this happen. I just came yesterday. The reason I was in New York was for a conference called ID 2020, which is sponsored by the UN and is about finding identity solutions for refugees. There are 1.1 billion people with a B in the world who have no reliable legal identity. Some of them are refugees, some of them were just born in an area where they don't do identity normally. This creates huge problems for people. People without identities are much more likely to be exploited, to have problems, to lack health care, to lack jobs. Good identity can help alleviate poverty and suffering for many of the world's poor. We're working with a partner called iRespond, which does vaccinations and other health care applications inside third world countries. iRespond is using their biometric systems along with Sovrin in order to provide immunizations to children in Africa and Asia, and doing great work. One of the primary use cases you'll see for a decentralized identity system is in the financial services space. We're working with partners like USAA, which is a large Texas-based member bank for the armed forces, and a dozen or more credit unions to use Sovrin inside the financial services industry. Surprising to me, one of the first places they went was they wanted a reliable way to identify people when they call into their support centers, because this is a area of, this is a problem area for them. And you've probably all been through this, right? You call up and they ask you for, your credit card number and the last 4 of your social, and then they say something like, can you tell me the last 3 transactions that happened on this credit card? Like, no. And if you wait 15 seconds, there's probably going to be another one from something else. So this is how they identify people in their support centers. They want to use Sovrin to help solve that problem. A more obvious problem that financial institutions have is the know your customer problem. All financial institutions are regulated under anti-money laundering laws to run through a know your customer or KYC process to get firm identities about who they're dealing with, who they're banking with, prevent money laundering and those kinds of problems, terrorist activities. This is a huge cost center for banks, a huge source of friction for what they do, and none of them really like to do it. If you think about what you can do with verifiable claims, if a bank does a KYC process on a group of, on an account holder and creates a verifiable claim for that, other banks can use that in a marketplace and pay the bank who actually did the KYC process for the information. This reduces the cost of the KYC process for the first bank and the second bank, so both banks save money. And the wider this is used, the more valuable it becomes. So it creates a way for the KYC process to be a lot less friction and a lot less costly. So where is Sovrin right now? We have an alpha network up with 8 validator nodes running. Validator nodes are run by different institutions, and there is a nonprofit foundation called Sovrin Foundation, which manages the legal agreements with the validator nodes. It's an alpha network because it's experimental, and we anticipate that we will reset the genesis blocks over the course of the experiments that we're doing on the alpha network. Once the alpha network has gone through all of its tests, we will launch the provisional network. The provisional network, we don't anticipate ever resetting the genesis blocks for all time. So the provisional network will be the real network. Why is it not the real network? The general availability network, we call it, merely because it's missing features. It will launch without some of the features that we anticipate, but it will be usable, and people will start using it for pilots. We anticipate that the provisional network will be up early next month, and general availability will happen as features complete through the fall. As I said, Sovrin represents the advent of a universal trust system, one that can be used by anybody in a flexible way to create trust through verifiable claims. In 1990, hardly anyone, except a few researchers at universities and other government contractors, could have envisioned a global communications network that solved communication problems universally. And yet that's what the internet provided us, and it's what we rely on today. It's hard to imagine this kind of universal trust framework today, but I believe that Sovrin is on the verge of providing one, and that will help businesses be more profitable and users be more secure and more private. I'm happy to answer any questions.
Thank you, Phil. Any questions?
Hi. How would the Hyperledger technology that you're referring to as the basis of this compare to, for instance, the one that gets publicity now, IBM's Hyperledger, and what would the differences be in either technology or operation, or in the future, how it would develop?
Yeah, so the code for that Sovrin runs on is open source, and as you implied, it is a Hyperledger project. So Project Indy at Hyperledger is the code that we use. And in fact, it's our code. We donated it to Hyperledger. Hyperledger anticipates that Project Indy could provide the identity platform for many of the other blockchain projects like Fabric and Sawtooth that Hyperledger is using. So it's not competitive with them, it actually is complementary. And they've been very open about their excitement of having an identity solution that is open source and available to them.
Any other questions?
I actually had that situation with USAA just today. I called into their support center and had to answer all those questions. So if you can solve that, I'd really appreciate that. That'd be great. So the session we had just before this talked about the idea of identity as kind of this utility, and this also follows up on that. Do we need to anticipate a kind of an AC versus DC, beta versus VHS format war, so to speak, in the identity space before it plays out? Or do you see there being room for kind of multiple systems, or how do you kind of see that? Yeah, so my personal belief is that there will be multiple identity systems that have different properties. One of the reasons why we're supporters of the DID spec is because it allows for interoperability. Sovereign trustworthy claims are based on a verifiable claim specification from the W3C, which again allows for interoperability. So we're hoping that there won't be an AC-DC kind of war, but there will be more cooperation as this plays out.
Thanks for coming and presenting this. Two things. One is, how does this fit in with ping? And you mentioned earlier, maybe it was over here, that many more identities are good. What are those? What's your thoughts?
How does it fit in with ping?
Yeah, I mean, is this complement or is this complement or replace it?
So I think it's complementary, and here's why. As I kind of alluded to in my slide about sovereignty, the fact that I am the keeper, for example, of an identity document with my driver's license and provide that claim to you, doesn't mean that you don't need an identity system to manage all of that stuff, right? So I think that organizations will still have their own internal accounts. Another example is, at BYU, we're going to provide transcripts to students as claims that they will hold and be able to take anywhere they want. That doesn't alleviate our university from the requirement of keeping track of what students did and who graduated. So we'll still need the systems that we have. So I think they're complementary. I think companies like Ping and others will still have lots of business selling systems that work with this to create their internal accounts. Other questions?
Running a little over as well, so Phil, you're going to hang out
Yeah.
for answer any questions?
Yeah, thank you very much.
Thank you.